Bismillahirrahmanirrahim. Welcome to the third part of 21st lecture of statistics and probability theory. We will continue with the topics simple linear regression and correlation. Correlation. It measures the degree of association between two variables. Let's suppose we have two variables x and y, and we have taken y at the y-axis and x as the x-axis, and by drawing the scatter diagram we can find out the correlation between those two variables. Like in the first graph, these two variables, let's suppose that here we have y and here we have x, and there is no relationship which we can see from the graph, so there is not any correlation between these two variables. Now in the second graph you can see some pattern, not very much close, but there is some increasing pattern in the plot, so there is a low correlation, and this is quite stable, and this is quite high correlation, and this one is the perfect correlation. As you can see that as one variable is increasing, the other one is also increasing. So this is the degrees of correlation. There can be no correlation, there could be low correlation, there could be high, and there could be perfect. So types of correlation: if you have the increasing relationship, like if one variable is increasing, the other one is also increasing, so this one is the positive correlation. And if one variable is increasing and other is decreasing, so this is a negative correlation. We can say this in this way, that if one variable is increasing, the other one is decreasing due to the increase of the first variable. So this one is the negative correlation, and here you can see that it is curved correlation, curved relation between two variables, and here we have the partial relationship between two variables. These are the types of correlation. Examples: relationship between income and years of experience, they obviously have correlation between them. Relationship between amount of rainfall and yield of rice. Relationship between price and demand of commodity. As you know that demand increases, that price will also increase. And from here you can see that as years of experience increase of any employee, his or her income will also increase. Relationship between nature of work and motivation to work. Relationship between height and weight. So all these have some correlation between them. So these are the examples of the correlation. Difference between correlation and regression. A statistical measure which determines the correlation or association of two quantities is known as correlation, whereas regression describes how an independent variable is numerically related to the dependent variable. Correlation is used to represent the linear relationship between two variables. On the contrary, regression is used to fit the best line and estimate one variable on the basis of another variable. In correlation, there is no difference between dependent and independent variables. That is, correlation between x and y is similar to y and x. Conversely, the regression of y on x is different from x on y. Correlation indicates the strength of association between variables, as opposed to regression reflects the impact of the unit change in independent variable on the dependent variable. Correlation aims at finding a numerical value that expresses the relationship between variables, unlike regression whose goal is to predict values of the random variable on the basis of the fixed variables. In regression, one variable is random and other one is fixed, whereas in correlation, not any variable is fixed. We are simply finding out the association between those two variables. Pearson correlation coefficient, we denote it with rho. This is a population parameter rho, and it measures the degree of association and the direction of the linear relationship between two variables. So this is Pearson correlation coefficient rho. This is population parameter rho. But as you know that population parameter is unknown, so we use the sample statistic, which is usually denoted by small r. As you know that mu is the population parameter Greek letter, and the sample mean is denoted by x bar. You already know this concept. Similarly, rho is the population parameter, and this r, small r, is the sample statistic which we will use throughout this lecture. Direction of correlations: positive correlations and association between increases in one variable and increases in other variable, or decreases in one variable and decreases in other variable, is positive correlation. That is, variable x is increasing, variable y is also increasing. If variable x is decreasing, variable y will also decrease. Negative correlation: an association between increases in one variable and decreases in other. So that one variable is increasing, the other variable is decreasing. So this is negative correlation. As you know that correlation is the measure of relationship between two items or variables, and we have explained this, what is positive correlation and what is negative correlation. Two variables increase together or decrease together will have positive correlation between them, whereas variables move in opposite directions will have negative correlation. Example: the number of gallons of gas pumped is positively correlated to the amount spent on gas. So this one is the positive correlation. Miles traveled is negatively correlated to the amount of gas left in your tank. So this is the way to calculate the Pearson correlation coefficient, which is R, and this is small n, summation x into y minus summation x summation y, whole divided by under the root n into summation x square minus summation x whole square into n into summation y square minus summation y into whole square, and the range of the r will be from minus 1 to 1. R will always between minus 1 and 1. So if R is equal to 0, there will be no correlation. As you can see, this is scatter plot, and this is correlation between them is 0. There is no trend you can see in this pattern, so there is no correlation. And here r is equal to 0.4, so this one is the positive number. So this, as you can see from this pattern, that's just the positive correlation. That is, one variable is increasing, other is also increasing, or if one variable is decreasing, the other one is also decreasing. And this is r is equal to minus 0.4. So this is the decreasing trend. You can see in the scatter plot, there will be a negative correlation between two variables. If r will be close to minus 1, the correlation will be negative. If r will be close to 1, so the correlation will be positive. And if there is r is equal to 0, so there will be no correlation. If r is equal to minus 1, it will be strongly negative correlation. Strongly negative correlation. So if r is equal to plus 1, it will be strongly positive correlation. So here you can see that this one is r is equal to minus 0.90. This is positive correlation. And r is equal to minus 0.50. This is moderately positive correlation. And negative correlation, r is equal to minus 0.90 is negative, strongly close to negative correlation, very close to minus 1. This is also negative correlation. There is no correlation in this case. In this particular case, r is equal to 0. R is equal to 0.50. This is the somehow partial correlation between two variables. This is but partial positive correlation. R is equal to minus 0.50 will be partial negative correlation. R is equal to 0.90 will be positive correlation, and R is equal to 1 is strongly positively correlated. So this one is the example. These are the data on height and weight. Calculate the Pearson's correlation coefficient for the given data. Let's suppose x is equal to height and y is equal to weight. So we have calculated all these calculations from this given data. Our summation x will be equal to, by summing this first row, summation y will come from summing this second row. Summation x square will come by taking the square of all values of the first row. Summation y square will come by squaring and summing the all values of the second row. Similarly, summation x into y will come 62 into 50 plus 72 into 65 plus 70 into 63. By summing it all, in the end we will get this calculation. By substituting it into the formula of the Pearson coefficient correlation, as n is equal to 10, we will have calculated from here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are 10 observations. So n is equal to 10. By substituting all these values, you will get 0.886, which is positively correlated.